Question 70. Find the row space and the rank of the matrix. So we have 3 rows. This is 70. And then this is 10, 6, 5, negative 3, 1, 2, and negative 7, 5, 8. Now, I'm going to do Gaussian elimination, and I try to avoid fraction. So make it 10, 6, 5, and I'm going to multiply this guy by, 3R2, and then 3, 6, negative 7, 5, 8. Okay, and then obviously I'm going to add R1 and R2. It's going to be 1 and 9 and 11. And it's negative 9, and well, just use the same old R1. So negative 3, 1, 2, negative 7, 5, 8. So now I'm adding 3R1 plus R2. So 1, 9, 11. It's going to be 0. So 3R1, 28. So 3R1, 33, 35. And then 7R1 plus R3, it's going to be 0, obviously. So 63 and 68. That is 77, 85. Okay. So now, how about divide by 7 R2? Okay. So 1, 9, 11, 0, 4, and then it's going to be 5. And then not only that, 1 over, looks like 17, R3. I think 17 goes into both number, and it's going to be 5. 17, I mean, wow, 4, yes. Can you imagine this? So this is 1, 9, 11, 0, 4, 5, and then 0, 0, 0. Okay. Now, you can go ahead and finish all the way. I'm sure if you look at the video, it will say, I'm sure it will say, the video probably go all the way to reduced echelon, but you know what? I'm going to stop here, and I say, okay, I'm going to use this too, okay? But if you look at the video, I'm sure they go all the way, and they say, let's click and see what they say, okay? And then, what is that? If you go all the way, they'll probably say at the end, oops, yeah, they probably say, I'm sure they will say it. You can check it yourself. Okay, come on. I'm trying to go to the video, man, and then whatever. So I'm gonna say you can check. So I'm gonna use this too as a the answer. So let me put the answers in there. So it is 1. Okay, here 1, 9, 11. Okay, here just to prove my point. You don't have to go all the way. That's what I'm saying. 1, 9, 11, and then 0, 4, 5. This answer is different. What I'm saying is this answer is going to be different from what this video going to show you. But see, I bet the rank is 2. The rank is 2, okay? Because there's a 2 non-zero row. So now, so let's submit the answer. Okay. So where's the submit the answer button? Right there. Okay. Yeah, let's see. See here? So you don't have to, once you have entire zero row here, you can pick these two rows as the basis. Okay? All right, next one. I'm gonna just go a little bit how to do that. Okay, let's go to the next one. Okay, now basically for the row space, I did that already. Okay, you do the same thing like I did. This difference is this is 3 by 4. Okay, so you do the row operation, and this one basis for subspace, the same thing. Okay, to the row operation, and then, well, this is the same thing there, step by step. But if you know how to do it, you don't have to try every one of them. So basically for the subspace, same thing to the Gaussian elimination. And then now let's look at the column space. Now this one, 75. 75, the column space. So I'm going to 2, 1. I'm going to do the same thing like your textbook, I'm going to do transpose of this. So this, this is column 1 and column 2 now becomes row 1 and row 2. Okay. Okay, so now, so this is our column 1. This is our column 2 because I did transpose. So now the row operation. So 2, 1, and then it's going to be 0 because -2 R1 plus R2. So it's going to be 3. And then 1/3 R2, 2, 1, 0, 1. And obviously 2, 0, 0, 1, go to 1, 0, 0, 1. Okay, so this is column 1. This is column 2. So the basis for the column space is 1, 0. Like I said, column 1. And then column 2. Okay, but you can also say using original or basis of column space, you can use the original column. This is a column 1, it's column 2. So you can say you'll have the same answer, 2, 1, and 4, 5. Okay. You will get same, they will, they will credit the same thing. Okay. So now let's try, there's another thing. Now this one, find the basis of column. So you have, well, this is a pretty obvious one. If you look at 76, 1, 3, 4. I mean, so this is, you have, this is only leading 1. This is leading 1. We have 3 columns, right? We have 3 columns. This column is 3C1. This is 4C1. So what is the basis? Basis for the column space is simply 1. Okay. Rank is 1. Okay. So this is, just type it. Basis is 1. Rank will be 1. Okay. All right. Next one is, now I did it again. This is, now you can do the row operation. So they're asking for column space. This is question number 77. They're asking for column space. So you do transpose of this matrix. You're going to get, 7, 2, negative 2, 2, negative 6, negative 2, 1, negative 3, 14, 4, negative 4, 4, negative 3, negative 2, negative 2, negative 6. Okay, I transpose. And do your Gaussian elimination. Okay, I'm going to just show you the result of the Gaussian elimination of the 77. And you're going to get this 1, 0, 2, 3, 0, 1, 0, 4, 0, 0, 0, 0, 0, 0, 0, 0. Okay. So you have, what do you have? You have first column. This is actually column 1 and column 2. Okay. So this is column 1. This is column 2 because I did transpose. So what is the basis? Column 1 and column 2. So you write the basis is column 1 and column 2. Okay. That's what I put the answer there. So you put column 1 original, what I mean, 7, 2, negative 2, 2, and then second column, negative 6, negative 2, 1, negative 3. Okay. And then for the column space, I use original column. Okay. I suggest you. Okay. So you don't make mistakes. So you get column 1 and column 2. And the rank must be 2. Okay. Rank is 2 because you got, you got two two vectors in the dimension. Okay. Okay, so that is that. And then what we already did the null space. Okay, we already did null space. Let's just try. I did 81, so we did pretty much everything. Let's try, how about 80? I think I did 80, didn't I? How about 79? 79, find the basis null space. So here, what that means here, you write homogeneous equation, negative 5, 18, negative 18, 9. So 1, negative 5, 9. 3, negative 15, 18. Negative 2, 10, negative 18. Well, 1/3 are 2, and negative 1/2 are 3. 1, negative 5, 9. 1, what is that? Negative 5 and 6. And this is 1, negative 5, and 9. Is that right? I should have, I could have. Okay, so okay, it doesn't matter. So 1, -5, 9, 1, -5, 6, and 0, 0, 0. So that is 1, -5, 9, 0, 0. That is 3, 0, 0, 0. Is that right? So that means 1, -5, 0, 0, 0, 1, 0, 0, 0. Okay. Wait a minute. What did I do? Here. I think I made a mistake here. Let me, I didn't have to change the row because first one, let me just do this. Hold on. I didn't have to, okay. Let me do this again here. So here, this is, now, let me just repeat this one, -15 and 18, and -2, 10, -18, and then 1, -5, 9. I just divide by 1/3 all 1, -1/2 all 2. So 1, -5, 6, 1, -5, 9, 1, -5, 9. Okay. So now, so this is 1, -5, 6, 1, -5, 9, 0, 0, 0. So here, so 1, -5, 6, 0, 0, 3, 0, 0, 0. Let me go one more step. So 1, -5 is going to be 0 and 0, 0, 1, 0, 0, 0. So what that means is C1 minus 5C2 equals 0 and C3 equals 0. Okay. So that means from here, so now, so this is free variable, which is what? C2, because I have a leading one and leading one here. So from here, C1 equal 5C2, where C3 is always 0. So C1, C2, C3. So C2 equal T. Okay, so C2 is a free variable. So 5T, T is 0. So it's going to be T510. Okay, so only one vector spans. So you write 510 there, 510. Submit the answer. Okay, that's it. So that is additional help you guys may need. This kind of short video, isn't it? Let me just go ahead and help you a little bit more. So I did 70s. Let's go to 60s, okay? There's some 60s, starting from 60. What is 60 here? So 60 here, right? 60. Determine whether S is a basis for P3. So S is now 4 negative 2t squared plus t3, and then negative 2 plus t2, and then 3t plus t cubed, and this is 5t. We're talking about P3, okay? So P3 has, how many vectors in the basis? 4 vectors in the basis. Okay, because uh, standard spaces is 1 x x squared, and then p3, so x cubed. Okay, so we have 4 vectors. Is that right? Okay, so it qualifies at least. Therefore, you need 4 vectors. There are 4 vectors. But now, whether these vectors spans, okay, all P3. So what we need to do? We need to do whether C1 of, if I call this V1 and V2 and V3 and V4. So C1, V1 plus C2, well, V2 plus C3, V3 plus C4, V4. If this is 0 vector, then C1, C2, C3, C4 must be all 0. Then it spans P3, okay? Then it is a basis. So let's find out. So here, it is same as 4, -2, 1, -2, 0, 4, oh, I need one more, okay, 4, 0, -2, 1, and -2, 0, 1, 0. And this is 0, 3, 0, 1. Last one is just 5t, right? 0, 5, 0, 0. Okay. Oh, this is a 4 by 4. Okay. So we can use determinant. Okay. In other words, if I call this A, if determinant is not 0, that means it spans P3 by the section in 3.3. Okay. If determinant is 0, then does not span, because it is the vectors are dependent. This is independent. This is dependent. Okay. So now let's find out the determinant. Okay. So now I have determinant of 4, 0, -2, 1, -2, 0, 1, 0. The reason I'm using determinant is a bunch of zeros. 0, 5, 0, 0. So now I'm going to expand this about 5. So this determinant is here. A determinant will be equal to now 4, -2, 0, and then -2, 1, 0, 1, 0, 1. Okay. So now, again, I got 2, 0 there. So I'm going to expand about this 1. So this equal to, determinant is 4, -2, -2, 1. Hey, this is a 4 minus 4 equals 0, singular. That means what? It does not span, is not a base, not basis, okay? Because determinant is 0, so it's not a basis, okay, here. Okay, so now let's look at the next one. See, it's not a basis. Okay, a bunch of zeros, so that's why I did determinant. Okay, 61. 61. Determine whether S is a basis for P3. Same question. So let's try this. How this one is different. Same thing. So I'm going to go ahead and not going to copy that. Come on. Okay, here. So now, so do the same thing. This is 7, -1. This 0, 0. This is t cubed, man, 0, 0, 0, 1. It's going to be a bunch of zeros as well. 0, 0, 8, 0. The third one is 0, 4. 1, 2, 3, 1, 2, 3, 4. Oh my God, 5 of them. Okay. Now, it's not a basic. Okay, let me explain. 0, 4, 0, 1, -1, and 7, 0, 0. Now, look at this. How many vectors in the basis? S has 7 minus t and t cubed, 8t squared, and then 4t plus t cubed, and then -1 plus 7t. Okay. P3, a basis of P3 has 4 vectors. Okay. So now how many vectors in here? 1, 2, 3, 4, 5. Okay. Since S has 5 vectors, the set must be linearly dependent. Then it's not a basis. Okay. So it is not a basis for P3 because it's got too many vectors. Okay. Just move this one over a little bit. What happened? Oh, here. Too many vectors. Okay. So it's not a basis. Okay. So that's just what it is. Okay. Submit the answer. Is that what it is? Okay. Yeah. Okay, it's not a basis, too many. Okay, so now if you look at 62, the same idea. Okay, so 62, you get, C1 of 4003 plus C2 of 1041 plus C3 of 1130 plus C4 of 0220. Now, if this guy is 0000, then means C1 equal to C2 equal to C3 equal to C4, all zeros. Then this means what? Linearly independent, then it's going to be basis, okay? So you try, for C1 plus C2 plus C3 equal to 0. Next one is C3 plus 2C4 equal to 0. And then 4C2 plus 3C3 plus 2C4 equals 0. And the last one is 3C1 plus C2 equal to 0. Okay. You solve this one using matrices, and then you can find the answer. Okay. So pretty much the same thing. Now, 63, well, might as well let's do that. 63 is S is 524 024 004. They say, is there a basis? Okay, so I mean, this we have no choice. 524, 024, 004. So this is 3 by 3 again. Okay, so two bases. So if I call this A, so if a determinant is not equal to 0, that means it is basis. Why? If it's not equal to 0, then if A is not equal to 0, then this will reduce to 100010001. Okay. So it will span, that means, C1 equal to 0, C2 all C3, then it will this set will span all R3. So let's find out what is the determinant. I explained about these. So it is 5, 0, and 2, 2. Obviously, 10 minus 0 is 10, is not equal to 0. Okay, then it is a basis. This is for R3. Why? Because S spans R3, S is independent, linearly independent. Okay, so it is a basis for R3. Okay, so submit the answer. Oh, I gotta, the second part. What is it? What's the second part? Now, if S is basis, then U is linear combination of vectors. If it's not possible, write impossible. Okay, so let's do it. So can you write, C1 524 plus C2 024 plus C3 004, and can I have 15 to 12? We are guaranteed, we are guarantee that we are for sure that there exists C1 such C1, C2, C3, okay? Because it spans R3, we said, okay? So let's find out. So here, how you want to do it? 5C1 plus 0 plus 0 is 15 right away. C1 is 3, man. 2C1 plus 2C2 is, what is it, 2? Yes. And then 4C1 plus 4C2 plus 4C3, therefore, equal to 12. So from this, C1 equal 3. So from this second equation, 6 plus 2C2 equal 2. That means 2C2 equal negative 4. That means C2 equal negative 2. Okay, so I have C1 equal 3, C2 equal negative 2. What is C3? So 4 times 3, C1, plus 4 times negative 2 for C2, plus 4C3 equal 12. So 12 and 12 cancel. Negative 8 plus 4C3 equal 0 makes C3 equal 2. So U equal to, how they want us to answer a certain way, right? S1, S2, S3. So U equal to 3S1 minus 2S2 plus 2S3. So 3S1, 3S sub 1. Where is the sub? Okay. Symbol? No. Relation? No. Function? Yeah. 3 sub S1 go minus 2 sub 2, okay, and then plus 2 S3 S sub 3 sub 3, okay. I think that's what they want us to do. Is that right? S1, S2, S3. Okay. Okay, so let's see. Okay, so that's out of the way. And then the rest of it, I think, are the same. Well, if you look at 64, I'm doing everything. 64, it says S is a set consists of 3 vectors, 0, 1, and 1, negative 1. Now, because it is R2, you know, one is extra. You mean right away, these two will, if I call V1, V2, if I call V3, what are the bases? Which one from the bases? Now, I know right away V1 and V2 because they are linearly independent. Okay, I want also, that's one, and another one, it'll be V1 and V3 because they are linearly independent. Okay, well, they use 0, 1, okay, fine. So this is, and also V2 and V3. V2 and V3. Okay, so V1, V2, V1, V3, V2, V3. That's it. Okay, you cannot have one vector. That's out of the question. So you have to have that, and you have to have that. Okay, like I said, you cannot have 3 because R2 basis for R2 has 2 vectors. Okay, so that's it. Submit the answer. Okay, so let's go to next one. So this, we already did it. Okay, so let's try something more. How about this one? This is find the basis for the dimension of vectors. Okay, so now at the end, the solution space. Okay, the solution space consists of this W equal. This is, I should say. Usually, this is the result of this. This is the result of. This is the result of C1, C2, C3, C4 is 4S minus T S 3T S. That's what it means. Okay. So this is S first, and then 4101 plus T negative 1030. So in this case, they want us to write in this way. So first one is 4101, and the other one is negative 1030. Okay, that's horizontally. 4101, you don't need a vector. 4, 1, and 0, and 1, and then negative 1, and 0, and 3, and 0. And what the dimension? Dimension is 2, obviously. Okay, so 2 vectors generate everything. Okay, here. Okay, isn't this like a piece of cake, you guys? Yeah. So now row vectors, we already know how to do it. Column vectors, you just write it basis for the row space. you know, basic for the, okay, I did it. Okay, this is it.